What's up, everybody? Today we're going to be solving a new problem in our LeetCode series, and this problem is related to the sliding window. So we're going to go and click on this one, which is best time to buy and sell stock. Let's go over on LeetCode and see how this problem is. So basically it says best time to buy and sell stock. You are given an array prices where prices sub I is the price of a given stock on the ith day. Alright, you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. The example is if you have a list of days actually. So basically it's like the price of a product on each day. So if you look at 5, this is the maximum profit you could get. On the day 1, you have the price as 7. On day 2, the price is 1. Day 3, the price is 5. So basically, buy on day 2, okay, when it's the most cheapest, the price is equal to 1, and sell on day 5, which is 1, 2, 3, 4, and 5, when the price is 6. Profit is 6 minus 1, which is 5. Note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. You can't just go back in time. You don't have a time machine or something like that. You could buy it on day 2 and come back on day 1 and sell it. No. So over here we have another example, and these are also the prices for a particular thing, but you could see it's just dropping down every single day. So in this case, no transactions are done, and the maximum profit is 0 because any day you buy it, you're just gonna never get a profit at all. So this is the price's length, and this is the price's I. These are some of the constraints. And seen this question in a real interview before, 1 over 5. So let's just start out. Okay, so let's go over here. And over here we have a class solution, public, and we have int maximum profit. This is a return type that we need. And we have a vector int, okay, ampersand means we're not creating a copy, but we're making a reference to that vector, so it remains the same. Basically it's the same data if you pass it through the main. But over here what we have here is the prices. Now what we want to do is find the maximum price, right? Int max price, and we could just assign it to 0. Okay, then we actually have to iterate through this, right? And see the prices for each thing. If we buy it on one day, we want to see how it correlates, right? But we have to use the sliding window technique. Like I told you, this problem uses the sliding window technique. So if we could say this as the maximum profit, I think that would be better. And suppose we got the most minimum price. We have to find two things. One is the maximum profit of the product that we could get, right, which is going to be subtraction, and the thing that we need to find is the most minimum price. So we say minimum price, min price, and that could right now assign to the maximum integer value. Okay, we could say int underscore max. So int underscore max C++ will tell you the maximum. It represents the maximum value of the upper limit of the integer data type in C++. The value of int max is this thing, 214748367 for 32-bit integers, and this thing for 64-bit integers. Alright, so that's the gigantic number, and then we have these two variables, and you could see that we are going to be looping through this, and we're going to be finding the minimum price, and we're going to try to change the maximum profit throughout this entire plan. So what we're going to do is, first of all, we're going to have a for loop, and we're going to go from int I is equal to 0. I is less than the prices dot length, or it's a vector, so you could say size. Then we have the I++. Now one thing over here is we have to get the price. So suppose we say minimum price, and we assign that to the thing. So it's basically prices vectors and then subscript I. Okay, if the minimum price is lesser than the actual minimum price, right? So we could basically say this as essentially we don't have to put this in a vector because we already have it. So I could just say if the minimum price sub I, so basically I could say if the prices sub I, minimum price, is less than the price right here, right? Then what I could do is I could reassign the price, minimum price, to this prices sub I. Okay, I hope you understood this. If the prices sub I, price is smaller than the minimum price, which is gonna be for sure, the first number is 7, then it's gonna assign to 7. Okay, now what happens is that it's just gonna keep on going until a certain thing. We're gonna have the else if condition, and this is if the if, like, suppose the minimum price, the price, actually the minimum price is actually the smallest, and the prices sub I, suppose, has 1, and that is basically going to get assigned. But when the price is 5 now, the minimum price is going to be greater than the thing, so it's going to come to this part, because we already have now price as, think of, it went through 2 times. So first one, it was assigned, minimum price was assigned to 7, alright? And the second time, the minimum price was assigned to 1. Now if I go in 5 and I say, okay, price is sub 5, which is 5 less than 1, that's not true. So basically it's going to go in the else condition, and in the else condition it says if the prices, which is basically the value, prices sub I, that 5, okay, minus the minimum price, which is this, which is on the first part. Okay, so the prices sub I, if that is subtracted, which is 5, which is subtracted with 1, is actually greater than the max profit. Okay, so we could basically say the max profit is equal to the same thing, prices of I minus minimum prices. So basically this is going to give us the thing after this for loop finishes up. So we could just basically return the maximum profit after this loop return. So basically it's kind of like a sliding window, if you understand. I am going from prices, suppose the prices, I'm going to dry run this and show you the complete explanation. So suppose there's an array and we have 7, 1, 5, 3, 6, and then 4. I go through this and I say the minimum max underscore max is basically this number. For 32-bit integers, suppose it's this one. Okay, 32-bit means 8, 16, 24, 32. So basically 4 bytes. This is the number. It's a gigantic number. First it's that one, and then after that this maximum profit is 0, minimum price is that, right? So we're trying to look for the minimum price here, and we go through this entire thing one by one. We go in the first element, which is 7. We check our minimum price, which is a gigantic number, and we say if that price that we just saw is less than the minimum price, and then if it was, it will just reassign it to 7, and next loop we'll go and we'll see it's 1, so it's just going to be reassigned. But when it's basically bigger than the actual minimum price, what we could do is we could subtract that 5 with the minimum price and see if that actual profit, so basically we subtract it and see if that actual profit is greater than the max profit. Well, of course in the first case it will be, so you can put the max profit as it's basically greater than 0, so the max profit, it will be the 5 minus 1, which is 4, and it's just going to keep going on until you see. Now the next time it will see 3, so if you check if the 3 is less than the minimum price, well, the minimum price is already 1, so it's just gonna keep going, and it's gonna keep going until you ever find another minimum price that's actually smaller. And then if you see that the it's gonna get reassigned, and then hopefully you could basically change the max profit for a certain condition and then return the max profit from here. So let's just run this code and see if this is actually working. So these are 2 cases, and what I'm going to do is I'm going to run it. So I'm going to say control and comma, or apostrophe, and you can see over here I'm going to compile time error because obviously I added this this thing. Remove that, and now let's run. Okay, so you can see over here that my solution was accepted, but I wanted to run it, so I'll say control and apostrophe, and then I can see my test cases here as well. So you can see over here output was 5, expected was 5, and then this one output was 0 and expected was 0. So basically it solved this problem. Again, remember, try to understand the mechanism here. We got 2 things. We cycle through these 2 things and we see if we find something that's bigger. So it's like a sliding window technique. Get the minimum price, keep changing the minimum price, and based off of the actual number, subtracting it and seeing if it's greater than the maximum profit and updating it. So it's just like 2 things, and then you keep doing it according to it. If you have a pictorial representation of this, you'll basically see that it looks like a window and it slides till the end of the vector. Alright, so that was it with this solution, and we'll move on to the next one soon. Peace out.